Hi guys, today we're going to be running a chi-squared goodness of fit test. So I went out and bought a box of Sour Patch Kids and I wanted to see if the distribution of Sour Patch Kids is the same for each color or if it's different from color to color. So the company claims that the Sour Patch Kids are equivalent in color. So our null hypothesis is going to be that the distribution of Sour Patch Kids is the same for each color, which would be that the probability of getting blue is the same as the probability of getting orange, is the same as the probability of getting green, is the same as the probability of getting yellow, is the same as the probability of getting red, which because there's 5 of them, that would be a 20% probability. Your alternative is that, we'll just use the quotes, is not the same or at least 1 p sub I is different. So the data I got, and I'll just write this up over here, orange, yellow, blue, green, red. Orange, yellow, blue, green, red. And I had 6, 6, 8, 8, and 9. 6, 6, 8, 8, and 9. And that is 37 total. So that should mean that these are my observed. Expected should all be 7.5 each. Because I took 37 and I divided it by 5. All right, so let's check our conditions here first. Random sample. We're going to say that this is a random sample of Sour Patch Kids. 2, your 10% condition, that 37 times 10 is 370. That's less than all Sour Patch Kids. And then your third condition, that your expecteds are all greater than 5, which 7.5 is bigger than 5. So that works out. Now remember, for chi-squared, you have to sum all of your observed minus expected squared divided by expected. So for example, you would take 6 minus 7.5 squared divided by 7.5, and then you would do that for each one. And then if you were to do that, you get a total of 0.966 repeating. So if you were to do that, each contributing value would be 0.3 plus 0.3 plus 0.03 plus 0.03 plus 0.3. If you have now a couple of choices where to look this chi-squared test statistic up. So this is your test statistic, 0.966 repeating. You can look it up in your table. Remember, degrees of freedom here is categories minus 1. So in this case, it'd be 5 minus 1 is 4. You can look that up in your table, or you can use chi-squared CDF, which would be your lower bound would be your chi-squared test statistic. your upper bound would be infinity or 1e99, and your degrees of freedom would be 4. Then you get a p-value of 0.914. So now our conclusion, we fail to reject your null hypothesis since 0.914 is greater than what we typically set our alpha value at, 0.05. We do not have evidence the color distribution is different or not uniform. Is not the same. So remember to write your final statement of your alternate or your conclusion in the format of your alternative hypothesis. This should say alternative. Meaning like we don't have evidence of that alternative hypothesis.